Answer this question in under 3 seconds. What's 12 times 13? If you had 156 memorized, that's ideal. But if you didn't, here's how you can figure it out on the fly in maybe 2 seconds using base multiplication. Both numbers are close to 10, so we'll use 10 as our base. 12 is 2 more than 10, so we write 2. 13 is 3 more than 10, so we write 3. Working crosswise, 12 plus 3 is 15. That's the left side of the answer. 2 times 3 is 6. That's the right side, so the answer is 156. Working crosswise in the other direction always works too. Just remember to pick the direction that looks the easiest. In a multiplication table that goes up to 15 times 15, each pair of numbers appears twice, well, except for the squares. For example, 2 times 3 will also appear as 3 times 2, and so on. So that cuts the work of memorization down by half. You already know how to multiply by 1, and by 2, and by 10, and probably have your 5s and a few others pretty much memorized. So that cuts the workload down even more. And you can calculate on the fly using base multiplication if you get stuck. Of course, memorizing your tables in the short run means less mental work later, so it's a smart idea to learn the tables to 15 as well as squares up to 25 squared. A great way to approach that task is to use flashcards. Set aside the answers you know and hold on to the ones that give you trouble. The pile of flashcards that are troublesome will get smaller and smaller each time you quiz yourself, until you've eliminated all of them. Answer this question in under 5 seconds. What's 13 times 14? Both numbers are close to 10, so we'll use 10 as our base. 13 is 3 more than 10, so we write 3. 14 is 4 more, so we write 4. Working crosswise, 13 plus 4 is 17. So that's the left side of the answer. 3 times 4 is 12, so that's the right side amount. But remember that the number of zeros in the base dictates the number of digits on the right side. The number we calculated for the right side exceeds the number of digits we're allowed. We're allowed 1 digit, but our number is 12. So we keep the 2, and we carry the 1 to the left. We add them together like this. So the answer is 182. Answer this question in under 5 seconds. What's 9 times 13? Both numbers are close to 10, so we'll use 10 as our base. 9 is 1 less than 10, so we write -1. 13 is 3 more, so we write 3. Working crosswise, 9 plus 3 is 12. That's the left side of the answer. -1 times 3 is -3. So here we need to subtract our right side rather than add it on. So let's write out our placeholder zeros. The base is 10, so there will be 1 digit on the right side. We can write 0 in that space for the moment. Now we subtract 3 from 120 to get 117. Answer this question in under 5 seconds using base division. What's 12 times 9? "12 is 2 more than 10, so we write 2. 9 is 1 less, so we write -1. Working crosswise, 12 minus 1 is 11. That's the left side of the answer. And 2 times -1 is -2. The base is 10, which has 1 0, which means there will be 1 digit on the right side. We can use 0 as a placeholder for the moment. 110 minus 2 is 108. In case you're wondering, it's possible to use any base number. You can try using base 100 to answer 9 times 13. You can try using base 10 to answer 88 times 104. It works, it's just very impractical. Okay, so how do you apply base multiplication to numbers which are really far apart? Take a look at this problem. The first number calls for base 100, but the second calls for base 1000. There's a simple way to handle the problem. Multiply the 95 by 10, so that we can use base 1000. That will give an answer which is 10 times too big. So at the end of the problem, we'll divide by 10. 950 is 50 less than 1000, so we write negative 50. 985 is 15 less, so we write negative 15. Working crosswise, 985 minus 50 is 935. That's the left side of the answer. Negative 50 times negative 15 is 750. That's the right side. So the gross total is 935,750. Divided by 10, that gives us a final answer of 93,575. So far we've used bases like 10, 100, and 1000. But it's possible to use base multiplication on problems like 48 times 46, where the two numbers being multiplied are nowhere near a convenient power of 10. So here we'll use actual base 100 and working base 100 divided by 2. 48 is negative 2 from 50, so we write negative 2. 46 is 4 less, so we write negative 4. Working crosswise, 46 minus 2 is 44. The left side number alone gets divided by 2 at this point, which makes 22 the left side amount. The right side is treated normally. Negative 2 times negative 4 is 8. But we write 0, 8. There are 2 zeros in the actual base, so there will be 2 digits on the right side of the answer. The answer is 2,208. Here again, the numbers are not close to 10 or 100 or 1,000. Let's use actual base 100 and working base 100 times 4. The working base is 400, but it's written as 100 times 4. That's to remind us to multiply the left side by 4. 411 is 11 more than 400, our working base, so we write 11. 396 is 4 less, so we write negative 4. Working crosswise, 411 minus 4 is 407. And now we adjust that number using the operation indicated by the working base. That is to say, multiply 407 times 4. 407 times 4 is 1628. 1628 is the left side of the answer. The actual base has 2 zeros, so the answer's right side gets 2 digits. 11 times negative 4 is negative 44. Let's put in 2 placeholder zeros and subtract 44. So over subtract and add back the complement. Subtract 100 and add back 56. Here's another one. Let's use actual base 100 and working base 100 divided by 4, which we know to be 25. 29 is 4 more than 25, so we write 4. 26 is 1 more, so we write 1. Working crosswise, 29 plus 1 is 30. Now we adjust the left side by dividing by 4. 30 divided by 4 is 7.5. If you get a decimal amount like this, just carry it to the right, but we'll come back to that. The right side, 4 times 1 is 4. The actual base has 2 zeros, so the right side gets 2 digits. Instead of writing 4, we write 04. With the carried 5, we get a final answer of 754. In base division, when you divide the left side, you may end up with decimals of 0.5, 0.25, 0.75, and others. They're simply carried directly to the right. We chose to work with working base 100 divided by 4, but an easier choice would have been 10 times 3 in order to avoid the division and carryover. So let's try it. In this example, our actual base is 10 and our working base is 10 times 3. 29 is 1 less than 30, so we write negative 1. 26 is 4 less, so we write negative 4. Working crosswise, 26 minus 1 is 25. Now we apply the operation indicated in the working base. 25 times 3 is 75. That's the left side of the answer. Our actual base has 1 0, so the right side gets one digit. Negative 4 times negative 1 is 4. Our answer again, 754.